Wake up one morning and it starts as a tickle in your throat, and you remember that feeling. And then a little bit later, that tickle develops into a sore, raw throat. Maybe by the afternoon, you've started coughing. Next day, your nose is running and you're coughing and your stomach doesn't feel so well. You have a headache. And you realize, yeah, I'm sick and it sucks. And after a couple of days, maybe that runny nose stops. Your stomach feels a little better. You're able to eat some food. After maybe a week or two, you almost relieve all of your symptoms. Maybe you have a lingering cough for the next couple of days, but eventually even that disappears. And you're back to feeling just the way you were. And that cold, that flu, whatever you had is just a memory. And the reason for that is because of your immune system. Today, I'm going to talk about the immune system, a little bit about why I'm giving this speech. And as a hint, it's not about COVID-19. We're going to talk specifically about pathogens, how they're detected, how our immune system is sort of programmed, where biology trumps what we can do with technology. And I'm going to start with a little bit of a disclaimer. During the research of this project, I learned a lot about white blood cells, different types of white blood cells known as T cells and B cells. And there's a lot of different terminology and words used. For the simplicity and the brevity of this speech, I'm only going to talk about the white blood cells in general at a high level and not get into all the specific details of the names of the cells and what they do. Suffice it to say that they all work together to help you stop this cold or this attack or whatever it is that has come against your immune system. Now, why did I want to give this speech? Now, you might think, well, we're still into COVID-19. We're into our fourth wave. Great time to give a speech about the immune system. But actually, for me, one of the reasons I get interested in the immune system is because of my background in computer science. Specifically, I love to specialize in something known as artificial intelligence. Can machines think? And in the world of artificial intelligence, we distinguish between two different types of intelligence. One we call weak or soft AI, and another that we call hard or strong AI. And believe it or not, all of the artificial intelligence that we've created to date as of 2021 falls in the realm of weak or soft AI. And the reason for this is the AI does a specific function. It's intelligent, but only within a specific domain. So if you think, for example, of your assistants today, like Google Assistant and Siri, they are really they can do some really neat things. They can set your reminders. They can set you a timer while you're cooking. They can turn on and off your lights. It almost seems like it's limitless what these AIs can do and understand. But let's say you were to ask a simple question to Google and say, and you can try this later, say something like, hey, Google, if Brad has 3 apples and Todd has 5 apples, how many apples are there altogether? Now, any child can answer this question that's of school age, will have no problem with it. But Google Assistant probably is not going to give you a correct answer. And it's not because it can't do it, it's because nobody's programmed that into the Google Assistant. It requires a person to alter the code of the assistant. So it's only specific within the domain that seems intelligence. In contrast to this, a hard or strong AI should be able to solve any type of problem that's presented to it simply by reasoning the way a person would do, or we believe similar to how a person would do. So a simple example of strong AI is, can I make a robot that I could put in anybody's house that would be able of finding the kitchen, finding the water, bringing me a glass of water from the kitchen down to a different room in the house? And it shouldn't matter what house it is. So again, any kid, any person could go into somebody's house and figure out how to make a glass of water. But can we get a machine to do it that would work for any house, that's general to any specific situation? And again, it's got to be general to all kinds of problem solving. We're going to come back to this later. But let's talk about the immune system, specifically these things called pathogens. So pathogens are any type of entity or organism that attempts to attack our immune system. This includes viruses like we're familiar with, the cold, the flu, or even COVID-19, but it also includes things like bacteria, things which may cause salmonella or food poisoning. It includes parasites like those nasty tapeworms and ringworms, and different fungi that our body can't handle that go into our immune system. So these are all referred together as pathogens. And they're all things that basically attempt to attack our immune system. Now, exactly how can our body detect what a pathogen is? So it's really rather interesting. All of the cells in our body have these little things sticking off the top of the cell, and they're proteins. And you can think of them like a fingerprint because each of these cells have their own proteins that stick out of them, their own fingerprint. And our body recognizes those as belonging to themselves. An invading cell also has these little proteins sticking out of them, but they don't match what our body is used to. And we call them antigens, but they're just proteins, things that our body doesn't recognize sticking off the cell. And the reason our body can do that is because as cells travel through our circulatory system, they have little receptors. And these little receptors match the specific protein fingerprints that our body is used to. And when it finds a match, it knows, okay, that's safe. And when it finds something that isn't a match, it says, aha, I found something that looks like an intruder. Interestingly, in the world of computer science and antivirus software, it works very similar. Although we use the word fingerprint, the programmer we use the word signature, not fingerprint. We upload into the antivirus software signatures of what different viruses look like. The antivirus software scans the memory and the files on the computer looking for these signatures. And when it finds one, it says, aha, I found a virus. So similar type of idea. Now, one of the interesting things about our immune system, there's these special cells called dendritic cells. And you can think of them a lot like Pac-Man. Their job when they find the invader is actually to consume it, to eat it, to absorb it. And that's how our body attacks the immune system, with these special cells that are activated, that go out, they find it, and they sort of absorb it and make it disappear. Now, once it's done this, basically what your body had to do is find the offender, create the specific dendritic cells that were going to go out and attack it, absorb it, and destroy it. This all takes time. To speed up the process, what our immune system does is it programs into these special cells called T cells, and at first they're known as naive T cells, but it programs how exactly it made that protein, made that type of immune response that was able to combat that specific pathogen. And what's interesting is it does it in such a way that not only can it cover that exact pathogen, it can do things that are similar to that pathogen that sort of kind of look like it. And it loads that into the T cell, and then it's called an activated T cell. What happens the next time that our body encounters a similar type of pathogen, it can then reuse the memory in that T cell to produce the immune response much faster. You see, time is of the essence. There's a lot of things a doctor will tell you when you're sick. Drink plenty of fluids, get lots of rest, maybe take a couple of aspirin, call them in the morning. And what's interesting is that our body responds, attacks, and destroys the majority of pathogens it finds without any intervention from us. We don't have to think about it. There's no conscious thought involved. It just does its job. And as long as our body can respond fast enough and destroy the pathogen before it multiplies too big, we're safe. But if our immune system moves too slowly at response, then the continued reproduction of that pathogen more and more and more and more into our system can cause basically us to die, become very sick, and eventually die if our immune system can't respond fast enough. So what's interesting is these memory T cells mean that the next time a similar pathogen hits our system, it can reproduce the necessary immune response fast enough to kill it before it gets any further. Part of my research on this, I was looking into bats, and what I found out is that bats contain many different types of diseases. They contain COVID and almost any disease you can think is in a bat already, and yet the bat shows no symptoms of being sick. And they believe that unlike humans, whose immune response takes time to warm up and sort of get ready and to attack the cells, the bat immune system is always active all the time, trying to stop the pathogen from invading itself. And because it never has this warm-up cycle, it can always keep beating the cell on a continuous basis, something that bats could do that human immune systems cannot. And this is the part that I find most fascinating, is this idea that there's these naive T cells that our immune system basically writes code for, programs with the solution to the problem inside the T cell so that later it can be activated and used again. There's no system yet that we've created where our code, where our software can program itself to solve a problem. And that's kind of the big mystery of hard AI, is how do we get the response, how do we get the system to be able to write its own code to solve its own problems when faced with a new situation? And yet, one single cell in our body is capable of doing that no advanced computer chip, hardware, or software can do yet today. Now, it's not a perfect system, unfortunately. It sort of makes guesses. Remember how when I said that when it codes this T cell, it sort of codes a guess to say, well, anything that kind of looks like this pathogen. So back in January of 1994, I got a cold, just like any other. I had a sore throat, had a tickle, I had a cough. Eventually, after a couple of days, I started feeling better. But a strange thing happened. My body created these memory T cells, which remembered what the invader looked like in anything close to the invader. Now, in all of our bodies, we have a special type of cell called a B cell or a beta cell. And the beta cell, just like any other cells, contain these proteins on the end, these antigens. And the memory T cells mapped to that and said, oh, that is also an invading cell. Now, it wasn't. It was actually a good cell. But my immune system looked at the triggers, looked at the proteins as close enough match. So it went ahead and it did its job and it said, I'm going to kill all these beta cells because they're dangerous. The problem is what these beta cells do is they regulate the amount of glucose. They're sensitive to how much sugar is in your blood, and they release insulin when your sugar levels get high. So as a result of this, in May, all of my beta cells were pretty much destroyed, and I developed what is called type 1 diabetes. So today I have to take insulin pretty much 2 or 3 times a day to combat the fact that I don't have these beta cells doing their job producing the insulin. There's actually research where they can put these beta cells back into your body. They can grow them in a petri dish and inject them back into you. And for about 6 months, you don't have diabetes anymore, except that, again, these memory T cells look at them, see them as invaders, go ahead and kill them, and then you're back to having diabetes. So while it's a very interesting system, while it can do things that no technology yet can do today, basically write its own code to solve a problem, it's not perfect and can cause things like diabetes. That's my overview of the immune system, pathogens, how it works, how it's better than technology, and how I got interested in it through the field of artificial general or hard AI, artificial intelligence.
Geek Wisdom.